Welcome to my talk about giants, liars, and slowpokes. I'm going to talk about unit test anti-patterns. I'm going to tell you a little fairy tale about a small unit test that wants to be a good one and wants to avoid these anti-patterns. But first, to be honest, I'm a bit nervous to be on such a big stage in such a big room. I didn't bring my remote control, so I have to go back and forth to my computer. But we'll manage. Okay. So, my name is Birgit. I'm from Germany. I'm a freelancing Java developer, mainly in the back-end area, no front-end. I've done this 20 years ago, but forgot all about it. So I'm in the Java and Spring ecosystem. I'm also very interested in software crafting, so I organize 2 software crafting communities in Germany. It's called DevBcn. Whoever speaks some German, it sounds very official, DevBcn. But it's just a community of people who are interested in good software crafting principles. And I also organize or co-organize the Socrates in Germany. There are many Socrates conferences all over Europe, I think. And I'm working on the one for Germany to organize this one. It's end of August in Soltau, so if you want to come, you can apply, and there will be a lottery, so if you win, you can come. But now, have a seat, make yourself comfortable. I'll be your fairy tale. In German, it's Märchentante, so I will be your auntie telling you a fairy tale. And every good fairy tale starts with once upon a time. There was this little test who wanted to become a really grown-up, good test. And so it wants to go out into the world and get some experience. And of course, when it's on its way, the parents of this test give it some good advice what to take care of on your way to become a good test. The first one is a test should always test the behavior of a system rather than the implementation. So this is the first advice they say. And the second one is a test should always add some value to the system rather than fulfilling some metrics. So it rather should be some sort of documentation or safety net and not chasing coverage or something like that. So those are the 2 advices from the parents. And of course, it should always be careful on its way. Think about which way to go, maybe look back sometimes. And stay in its own country, in country meaning in its own domain, not going outside of its domain. And, of course, have fun being a good test. So, while it's on its way, it meets the first kind of villain. And this is the liar. Do you know this Pinocchio figure? Yeah, so. So what, I would ask you, what would you think? What is a lying test? What does it do or not do? Any idea? doesn't test anything? Yes, something like that, yes. So you have tests that pass, but they don't really, actually they don't test anything. They are just chasing test coverage. Or those are tests which maybe test something, but the name of the test doesn't tell you its intent. So it's lying to you about its intent. You first have to read the test and to truly find out what's going on. So this is called a liar. And an example is, as I said, a test with no assertions. It's also called the line hitter sometimes, so a liar or a line hitter, or a test name that doesn't fit what's inside the test. So the cause could be, I should write tests just to get the coverage. Actually, I forgot, I wanted to ask you, who of you is writing tests? Okay, that's many. Who of you is doing it by free will, so to say, because they want to write tests? And who of you is writing tests first? Okay, still a few. Okay, so you are not the ones chasing test coverage, I hope. Just yes. So always be careful. I'm always doing it like this. When I find tests with no assertions, I just delete them. They do nothing, so I just delete them. Or if you find a test which does something and tests something and the name doesn't fit, so just refactor. You can refactor tests. Or you should refactor tests, even. Okay. So our test is on its way. It's past the liar. It's left the liar behind. And comes along this wall. There are a lot of numbers on it. So those are tests named, or they're quite similar to the liar. Those are tests named like test 1, 2, test 3. So I see smiling faces, so somebody has done it. I have done it. So yeah, it's still a liar, but also an enumerator test. So you have to really read what's inside the test to find out what it does and why it's there, and pray for some clarity. And the liar could be, sometimes I have it myself that I write a test, but I don't really find a name yet. So I don't want to think too hard about the name. I just write test something, maybe. Test something is same as test 1 through 3. And only later, when I thought about a name, then I changed the name, but I will change the name. Or if you have like things, more than one parameter to test, with the same kind of test, you write something like test 1, 2, 3. Yeah. But you could as well use a parameterized test. That's maybe something to think about. And you never should leave these enumerators in your test source code. Never ever do that. Just rename them, give them proper names. Okay. Another anti-pattern, the happy path. I think many of us have done it, so we just test the one path that seems to be obvious, and we don't look left or right or above or underneath us. So we should also go the not so happy path and test the boundaries of our system. And yeah, that's really the definition. The anti-pattern here is that we have a test, and it's doing something, it's doing it good and right, but we stop at this happy path. We don't look left and right. So we should always check the boundaries, check exceptions, and things like that. So an example would be, I just write one test per unit, the one and only happy path. And yeah, I try just to prove the correctness, but not the incorrectness maybe of a system or of an algorithm. A good help here is, some of you do it already, is the test-first approach. Like test your boundaries first and then go to the happy path. And yeah. Maybe if you want to find out whether there are missing tests or whether you should test some boundaries, one thing could be to use mutation testing. Who has seen my talk last year about mutation testing? Okay, so you know how to do it. Or maybe another thing would be to use property-based testing, but I can't tell you too much about that. I haven't done much in this field. So, yeah. Okay. So the happy path leads to this beautiful castle. And it says excessive setup. So what do you think is that? The name says it already, maybe give some hint. So anyone? Sorry, okay. This is really hard because of the background noise. I can't hear. So actually it's a test where you have to do a lot of upfront setting up before you can test anything. And you might get lost in the setup and yeah, miss the thing that you really want to test because of all the noise in the background. So yeah, you have several hundred lines of code to just set up a test. And I'm talking about unit tests, not necessarily acceptance tests. Okay. So you probably mock out a lot of dependencies. You have to write a lot of code to form a scenario. Or in Spring Boot, we have this context thing. You load up the whole context of your application just to test something. Actually, in Spring Boot, you wouldn't write 100 lines of test. You would write one annotation at Spring Boot test. But you should still think about it. Excessive setup. Maybe your class you're testing or your unit you're testing is not always a class. It's too big. Maybe you can factor something out, do some approving of abstraction or separation of concerns, and yeah, just think about why do I have to build this big setup just to test something small. It's a hint for you that maybe your class is too big or is doing too much. And one suggestion is to practice object calisthenics. Who's heard of object calisthenics? Okay, some of you. I have to, object calisthenics is just a few rules you might follow writing classes or writing source code. It's, as I said, it's rules, and you don't have to follow them strictly, but maybe try to follow them up to a point. The one rule is one level of indentation per method, so not having like lots of indentation. Don't use the else keyword, it's another rule. Yeah, okay. Wrap all primitives and strings in classes. Those, yeah, if you have a variable, maybe representing a year, instead of using an int for a year, just create a class year with an int inside. So you're type safe. You can be type safe. 1 dot per line, so when you call something else, just don't concatenate dot after dot to call something deep inside the structure. Don't abbreviate. It says keep all classes less than 50 lines. Well, okay. Sometimes it works, or most of the times in my work, sometimes not. And then it says no classes with more than 2 instance variables. Okay, can be hard. And no getters and setters, so strive for immutability. Getters, yes, okay, you might need them. Okay, that's object calisthenics, just you can look it up, maybe. So, in this castle lives a giant. So, a giant, yeah, probably something similar to the excessive setup, because that's why the giant lives in the castle, but not quite the same. It's, you have a valid test, or valid tests, but there are so many tests in your test class that you lose track. You don't know. You have to scroll and scroll and scroll to find the test you're looking for, or you even put in comment lines to say, from here on I test this part of the class, and from here I test another one of this class, part of this class. So this is also a hint for something not being quite good in your class. One example I find is those infamous utility classes. So you put something into a util class just because it might be usable by others, but in fact it's only used once in your code. So why put it in a util class? Just put it where it belongs and then test it there. And the util class tends to, or the test for util classes tend to get this big and long things. So same thing here, separations of concerns, dependency, keep them low. That's actually always the advice. Look at your class, whether it's too big when your tests become too many, and or maybe you have written accidentally because the giant is so long, you have like tested the same thing twice, but you didn't know. Okay. Any questions so far? Okay, good. And in this castle lives another, nice creature, really. It's called the mockery. You probably guess. It's sometimes mocking is good, you need it, but sometimes it can distract you from your test. I've even seen tests that test the mock. Really. Or a test that mock a mock. Or a mock that uses another mock. Something like that. So be careful with mocking. I don't say don't use it. It's all the anti-patterns. I don't say don't ever do this, but be aware of it. And so an example would be, I have, again, lots of dependencies I need to mock out just to test something. Sometimes you even need to partially mock out something of the class you want to test. I've seen that too, that just to test a part of your unit, you have to mock out another part of your unit. This is also an indication that your unit is doing too much. Your class is doing too much. You have to refactor. Or maybe sometimes you don't even recognize that you mock out so much because all the frameworks, they're so easy to use. You just write add mock. Good, easy, simple. Maybe just try to write the mocks yourself for once, and then you see that something is wrong with the unit you want to test. And again, separation of concerns, so this is always a big issue. Okay. And another creature living in this castle. I had to put one cat slide on in my presentation. The inspector. The inspector, yes. What do you, okay, it's very noisy. I don't ask. What do you think it is? But it is when your test, or when you modify your source code just for your tests, so that you can test your source code. It breaks encapsulation. So example would be making a method public, or in Java it's package private just to make it testable, but in fact it should be private. It should be a private method. And or just write getters and setters just for the test, but in fact in your source code you don't really need it. It's just used by the test. This is a thing I would say never ever do that. There are only rare excuses to do it, but not really good ones, I think. So that's what I said, just making methods public. And again, here can help you a test-first approach, where you write tests for your business code and then implement it, and then you refactor your business code and you refactor out private methods in your business code. They are tested because you already wrote the tests. And never ever do it, this breaking the encapsulation just to get your test coverage high. The test coverage doesn't tell you much when you break your encapsulation. So the point here is design for testability and not the other way around. Okay, so our test still is in the castle, found the inspector, found the mockery, found a giant, and now it's in a room where it finds this guy, the local hero. Local hero. Okay, what could this be? Actually, those are tests that depend on something to be installed to run. And this something probably is only on your machine and it works for me. Runs on my computer. What could possibly go wrong? And then you push it, and then Jenkins or whatever build engine you have comes in, and it doesn't have this thing installed, and the test breaks. And then you go and it's like, what? It runs on my machine. Why doesn't it run on this machine? Sometimes it's hard to find out these kind of things. So maybe it's something operation system specific you're relying on, or so you're developing on a Windows machine and the build runs on a Linux machine. This can be or you rely on something that is installed for your test. So actually, you should avoid to rely on things like that. So you should always either use, as I said here, for example, some in-memory database, or use test containers, or just use the libraries of a tool you depend upon, and things like that. So. So one could say, okay, then you could install the thing on the build machine as well, but maybe it's not possible because it's a Linux machine. Yeah, okay. Something similar to the local hero is the hidden dependency. So this is something, it's called the cousin of the local hero. It's a test that requires some existing data somewhere in a database maybe, or before it runs. And if the data are not there, the test crashes, and you really have a hard time to find out what's going on. Those tests can really give you some headaches, some really bad days before you find out. So the solution is always, the test should always set up test data for itself, and also maybe clean up after itself. So never depend on data being there by some magic source just to run your tests. Okay. And then outside the castle, there's this scary lying waiting for our little test, the loudmouth. The idea is that tests shouldn't clutter the console with lots of logging messages. The logging messages should come from the business code, but not from the test code. So sometimes, of course, you use it to find out what's going wrong. You have no idea, you put in some log messages, but always just delete them afterwards. as I said, you can refactor tests. You should refactor tests. So you shouldn't make your test too chatty. The chatty part is in the business logic. Yeah, that's actually what I just said. Okay, and then our young test is going up, and it's advancing on its way, going its path, and then there's this little snail, slowpoke. It's called coming along. So these kind of tests remind you that I'm still speaking about unit tests and not integration or acceptance tests. Those tests, they run so incredibly slow that you always either only run them just before you're about to go home, or you're craving for another coffee, but because they take so damn long to get finished. So just try to avoid these kind of tests, or just try to maybe make them faster somehow. Maybe if you're really testing some time-consuming algorithm, maybe don't test it with all the possibilities of data that go in there. It's just maybe find the ones that give you a good feeling that the algorithm should be fine, should be okay. Or when you do some asynchronous testing, then yeah, maybe you find a library or a framework that helps you with it, and just don't put in like waits everywhere and for 10 seconds, and it goes wrong one time, okay, 15 seconds, and it will go wrong another time, and then you have to put it to 20 seconds. This doesn't help you. So, or consider running them not as often, but after, consider it carefully, whether it's worth it not running them that often. Okay, this slowpoke. Then there is another anti-pattern. It looks nice, I mean, the sequencer. There's some, so our test came along the way, and somebody put up those stones. It looks nice, huh? So what could this be? What kind of anti-pattern? Actually, it's something when you rely on the order of something, like some data in a list. You depend upon that they come always in the same order. Your test depends on that. You never should depend on the same order. So you might read locally something from the database, you get it in a certain order, but as I said, on the build machine, they read from another database, maybe it comes in a different order. Who knows? So your test shouldn't depend on the order of data coming. Either you could say, okay, if you ask a database, give it in a certain order, then it's always ordered, okay, you could rely on this one, or your test shouldn't rely on the order. Yeah, those things are hard to find, I think, because usually when you're on a local machine, usually everything comes in the same order, and then it crashes on the build machine, and you have no idea what's going on. Then you have to debug on that build machine. Maybe it's, ooh, you don't want to do that, really. Okay. And there's the last one. It's called generous leftovers. those are tests. We had the test that was depending on data being somewhere already or something installed. And the generous leftovers is something that it depends on that some other test might leave some data for this test you're writing. So once the tests are running in a different order, which is not guaranteed in which order they run, then you don't have the data that you want to use. So as I said, always create your own test data for your tests. Because the test frameworks usually don't run the tests in a certain order. And that's also a second point. You should never write tests that depend on other tests being run before that. So never rely on the order of the tests, in which order they are run. Okay, those were the patterns I found. I mean, there are many more, but during discussions with other people about what other kind of anti-pattern could you imagine? I thought about what I don't like in tests. I would consider an anti-pattern. And this is something like a try-catch inside tests. So you do try something, then write the thing you want to test, and then this might throw an exception and you catch it in your test. There are other means to test exceptions, and you shouldn't. If the code you're testing throws an exception, just let the test method throw this exception. It will fail anyway. You don't need a try-catch block. I consider this an anti-pattern as well. I don't have a catchy name for it. So another one would be inheritance, like you have abstract base tests of some sort, and then there's another test that extends this, and another test that extends this one, and it's just to set up maybe some data for the tests, and then you have to click through and find what's going on, and after the third click, I'm lost. I'm totally lost. I don't want to look at those tests anymore. That's what I say. I think, this is my opinion, every test should prepare its own test data and not rely on some hierarchy of tests. And another, you could argue this one test per method thing. That your unit is always a class, or your unit is always a method, or so just one test per method. Maybe a unit is something a little bigger than just a class or just a method. So think about this as well. Okay, so our little test has grown up. It sees light at the end of the wood it's going through. It avoided all the villains, hopefully. And from here on, it's happily ever after for the test, for our little test. Okay. Yeah. That is what I wanted to tell you. I have some resources where I found all these anti-pattern, and there are many more. They have also nice names. But I found those the most important ones. the ones I showed you. Okay. Time for question. I hope I can hear you. Oh, and there's a microphone. Oh yeah, yeah.
Would you do fuzz testing? Would you advocate fuzz testing? Fuzz testing.
First testing?
Fuzz.
Fuzz testing. Never done it. I can't talk about it. I've never done it. Never. Yeah.
Like
so I can't.
Testing with random input data. Randomize input data as much as possible.
Yeah, I think these property-based testing thing kind of might. There are frameworks for it, and you define properties, and then the frameworks generates input data for that. Yeah. Even though I've never done it, but yeah, it's probably be worth having a look how this works. So it's called property-based testing. It's not to be. There's parameterized testing, there's property-based testing, and there's mutation testing. So, not to mix it up. Okay.
Hello.
Hello.
So thank you for the presentation. It was really cool. I was wondering how you are fostering TDD in your company, and if you are succeeding. Did you get it?
I didn't get the question.
So I'm asking, how are you fostering and trying to empower TDD, test-driven development, in your company, and if you are succeeding?
I do TDD for myself, yes, and I love it a lot. For me, it's still a learning curve. It's sometimes hard I have to remind myself, write a test first, and then do the implementation, because obviously a lot of times the implementation is already somehow in your head, how do you want to write it, and then, but I try to practice it most of the time, and I also love pairing with other developers, and I always, this is kind of a game we play. Then you write a test and I write the implementation, and then I write a test, you write the implementation. So this is much easier, and it's lots of fun. It can be lots of fun.
Cool, thank you.
Hello, thank you again for the talk. So I agree with you that the coverage is not enough. I mean, if you have low coverage, it means that you are missing a lot of tests. But if you have high coverage, doesn't guarantee you have a good test. But do you know some tool that could help us to detect if how many anti-patterns do we have in our system, or some, like the same way that Sonar can help you with the mutation test, or something like this? With a quick view, we can realize how bad are our tests, or something like this, or doesn't exist?
No, a tool that finds out the anti-patterns? No, I don't know. But yeah, as I said, mutation testing could help you with finding missing tests, and also finding bugs because of the missing tests. And yeah, other than that, no, sorry.
Hi.
Hi.
Thank you for the talk. So my question is about unit test boundaries. So you were mentioning a couple of times how we test data coming from the database or from some other input source, which is, from my personal view, sometimes goes beyond unit testing. It kind of gets into the way of integration testing. But on the other hand, we do have to test how we write, I don't know, SQL, how we write other queries. And sometimes when the unit test is testing something which basically infrastructure dependent, that infrastructure failure can actually get in the way and give you false negatives of your test. So where is the boundary? And is there a technique saying, okay, this is still a unit test, this is something still fast and testing just a single thing versus integration test, okay, yes, we're testing how we integrate with this source of data or something.
So I would argue a unit test stays within the boundaries. It doesn't need to really communicate probably with the database, but you can mock this one out. And when you have integration tests, you need this database to test the communication with the database. And you can't mock it out anymore. Some say as soon as you have to do some sort of I/O, it's an integration test already. It depends. If you have like what I do sometimes, you have to read in some data for your test from a file because otherwise it's taking up too much space inside the test code to produce some sort of input. I have to read the file, so I do I/O. Is it an integration test? I would argue no. It's still a unit test. But well, yeah. I would say you have this kind of test pyramid, and you always see pictures where it's cut into 3 parts. I would argue, and with the unit test being in the bottom part of it, but I would argue those things are flowing into each other. It's not a strict thing like this is a unit test and this is an integration and this is and there are strict rules when what is what. So you have to I think you have to find a way inside your team how to define where you draw the line for unit tests and where you say it's an integration test and where it's another form of test. Okay. Well, thank you.
If you have any more questions, you can use the mobile app. So there you have this section, Session QA, and you have the session, so you can just put the questions there, and she will go answer it during the day. Thank you.
Okay. And there's a link to the slides